In this video, we're going to learn how to balance chemical equations. The law of conservation of mass states that in a chemical reaction, the mass of the products must equal the mass of the reactants. If it doesn't, there would be leftover atoms, and we can't have that. If we look at the example of burning methane and count all the atoms on the reactant side and the product side, we can see that this reaction isn't balanced. So if we see here, we have one carbon on this side and one carbon on that side. So that is balanced. If we look at the hydrogens, there's 1, 2, 3, 4. Whereas over here we only have 1, 2, so that's not balanced. And then we have 1, 2 oxygens on the reactant side, but 1, 2, 3 on the product side. So we don't have balance. So if we decide to balance the hydrogens first, we could have 2 water molecules. So that would give us 1, 2, 3, 4 hydrogens. And that now makes there be 1, 2, 3, 4 oxygens on the product side. So if we put a 2 right here, now we have 4 oxygens on the reactant side too. So you need 2 molecules of oxygen to react with every molecule of methane, and that will produce 1 molecule of carbon dioxide and 2 molecules of water. And now it's balanced. Now word equations tell us what's happening in a chemical reaction. So in this example we have iron and oxygen, which are our reactants, and that's forming, the arrow points to the direction that the reaction is going, iron 3 oxide, which is our product. Skeleton equations are like word equations, except every chemical name is replaced with its chemical formula. So in the example we just talked about, this is the symbol for iron, this is the symbol for oxygen, and there's the symbol for the iron 3 oxide. So the way we balance chemical equations is we first of all write out the skeleton equation if it hasn't been done for us. We count the atoms on the reactant side and the product side and see where we're out of balance. And then we multiply each chemical formula by the correct coefficient to balance out the atoms in that molecule. So we're going to work through our first example. So we have magnesium plus oxygen making magnesium oxide. Now, some people find it helpful to keep a tally on the bottom. So I would draw like a dividing line along where the arrow is, so we can keep separated between reactants and products. And then I would write down the 2 different types of atoms. So we have magnesium atoms and oxygen atoms, and then we count. So right now we have 1 magnesium on the reactant side, and then we look over to the other side and there's only 1 magnesium there too. If we look at the other one, we have 2 oxygens on the reactant side, but only 1 on the product side. So we take a look and we see that our equation is not balanced. So we need to find a way to make there be 2 oxygens on the product side. So the way we can do that is put a 2 in front of the magnesium oxide. That's the only place you can put numbers to multiply. They can only go in front of molecules. They can't go in between atoms. So that will make us have, we'll change our numbers here now. We now have 2 oxygens, which is great, but now we also have 2 magnesiums. So that throws magnesium out of balance. So the way we can get 2 magnesiums on the reactant side would be to put a 2 right there. And now our equation is balanced. So 2 magnesium plus oxygen gas makes 2 magnesium oxide. Our second example is the reaction between hydrogen and oxygen to make water. So again, we can do this. This may or may not be helpful to you. You don't have to do the tally at the bottom. If you can do it all in your head, that's fine. So we have 2 hydrogens on the reactant side. We go over here, there's a 2 beside the hydrogen there, so we have 2 and 2. We have 2 oxygens again, but only 1 over here. So again, we're not balanced. So to make the oxygens balance out, we'll have to put a 2 here, and that's going to change this to 2, but it's also going to change our hydrogens to 4. So every number we put, we throw other things out of balance, so then we have to go back. So if we have 4 hydrogens on the product side, the way to get 4 over here would be to put a 2 in front of H2, so 2 times 2 is 4. and now we're balanced. So 2 hydrogens plus oxygen makes 2 water molecules. We'll go through another example. So we'll draw our line. We write our atoms, so we have iron and oxygen. So now we'll count. So we have 1 iron on the reactant side, 2 on the product side, and we have 2 oxygen on the reactant side and 3 on the product side. So we need to find a way to balance out oxygen so that we have the same number of atoms on both sides. So in this case, we need to look at something that both 2 and 3 can multiply to make the same number. And so the lowest common multiple would be 6. So we need to multiply one side by the number that'll make 6 for oxygen and the other the same. So if we put a 3 here, we'll have 6 oxygens. And if we put a 2 here, we'll have 6 oxygens. But we'll also alter our irons so that we have 4, because 2 times 2 is 4. So to finalize our balancing, we need to cross this out, put a 4 here, and then we have 4 and 4 for the iron as well. So our balance reaction will be 4 iron atoms plus 3 oxygen molecules make 2 molecules of iron 3 oxide. Our last example has more atoms to trace and follow along. So we have carbon, we have oxygen, and we have hydrogen. And the oxygens are found in multiple places. So we'll have to make sure we don't miscount. So if we take a look at carbon, we have 1 on the reactant side, but 6 on the product side. We have 2 oxygens here, plus 1 there. So 2 plus 1 equals 3. We have 2 hydrogens right there. And then if we go over to the product side, we have 6 oxygens here and 2, so we have 8. And then we have 12 hydrogens. So we're going to leave that alone. So we're obviously not balanced. So the first thing we could do is balance the carbon. So we have 1 here and 6 on the other side, so we can put a 6 here. So we have 6. Now let's look at what we've done to our oxygen. So 6 times 2 is 12 plus 1. So now we have 13. So that's not going to be balanced. So I think we need to jump down to the hydrogens next to balance, and then we'll take care of oxygen after. So if we look at hydrogen on the product side, we have 12, but we only have 2 here. So to balance that out, we need to put a 6. So 6 times 2 is 12, so that's good. And now we have 12 oxygens plus 6 more, so that's 18. So our oxygens aren't balanced yet. And we only have 8 on the other side. So if we figure out what we need 18. So if we put a 6 here, we would have 12 plus 6, and that would be 18. So to balance this equation, it's 6 carbon dioxides plus 6 waters makes 1 molecule of glucose plus 6 oxygen.